If we want to understand the resting potential, we need to first introduce two basic phenomena in nature: diffusion and electrostatics. Diffusion is the process by which particles spread out or mix, for instance in a solution. Here I'll take a bit of dye and a beaker filled with water. I drop a bit of dye into the beaker and I wait. After the initial splash of the dye falling into the water, the dye spreads out very gradually, over the course of hours, until it's uniformly distributed in the water. This gradual spreading is diffusion. The movement of the dye is governed by the thermal movement of individual dye molecules. They're basically jiggling at an atomic scale and bumping into each other. The result is a sort of drunken random walk of any given particle through the solution. In the aggregate, the process of diffusion causes particles to move from regions of high concentration to regions where the concentration is lower. Even though it's a purely random process, for all intents and purposes, we can think of diffusion as an inexorable force driving particles down a concentration gradient, from high to low. This process turns up all over biology, and it's essential to life as we know it. The second key to understanding the resting potential is electrostatic force. We already alluded to these forces when we were talking about batteries. Let's dig a bit deeper into what's going on. Particles can have a charge associated with them, positive or negative. These charges serve as the basis of all electricity. Positive and negative charges attract one another, and like charges, positive and positive, or negative and negative, repel.